actually inherently imprecise. But it has a mass. We denote it as an M, and a negative charge E. And we know also from relativity theory, the mass will change with the velocity. And we also know from Compton scattering, we have Compton wavelengths of electron, which is h divided by mc. But this relative light in vacuum, the mass of the electron is non-constant. And when you have the wave-particle duality, you also Dirac introduced the wavelength for the electron as Dirac wavelength. And wavelength is a function of this mass and velocity. And then eventually, in order to interpret this atomic spectrum, one has to introduce the concept of spin, which is 1/2 h bar, and the magnetic moment of E h bar divided by 2mc. In 1930, Schrödinger derived the Zitterbewegung consequence of the Dirac theory. But not many people believe it, especially quantum field theory people do not think this is a fact. They think it's kind of a mathematical artifact. Anyway, we put it here. In his work, what he has is, if you have this kind of trembling motion, the frequency is 2mc divided by h bar, and amplitude is something similar. Well, if you mention somewhere as length of quantum wavelength. And this is well known. Dirac developed Dirac equation where there is inherent entity which was not understood in the beginning, and later it turned out it has to be an antiparticle of the electron, named positron, and there is an association of the electron to the positron. And this was later after the war. So the macro measurement, actually first the rotation proposed, maybe there is an anomalous magnetic moment associated with the electron, and the measurement revealed it was this much, and then they come to quantum electrodynamics to make this correction. Yeah. So, as I said, I will not give technical justification why you do it. I happened to find a sentence written by Roger Penrose in his written book, Road to Reality, where when he talked about reality, he posed about the questions, what and why questions and answers. I've tried to read it, hopefully not too boring. And the modern science would be cautious in attempting answer to why questions as well as to what. Yet questions as to what and why are frequently supplied with answers. It is considered acceptable to do so, provided that the questions are not asking about reality at its deepest levels. One may expect an answer to such a question as the following: what is a cholesterol molecule is made of, and why is uranium nucleus unstable? Yet, some other questions one might pose could cause more embarrassment, such as what is an electron? He felt this kind of, first of all, it's a question, and secondly, it's kind of embarrassing question. Well, hopefully the answer is not embarrassing. And then there are some more questions posed by a theoretical physicist. He asked, what is really an electron? What is the structure which gives it spin? Why there must be a positron? And what is the mass? Why and how the electron manifests wave properties? And what is the interaction between two electrons, or between the electron and the positron at shorter distance? And these questions, he said, in fact, the history of the electron show that although there has been a tremendous progress in detailed application of electron theory, the progress in the foundation of physics is very slow. And then there's another person, this paper I found after everything was done, so I thought it was still quite illustrating to present here. Is that it's fair to say that there is today an explicit tendency not to encourage inquiries into the specifics of shape and topology of particle structures. This work philosophy is based on perhaps a vague conviction that the pursuit of such a knowledge has no meaning, or what the goal is believed to be outside the presented domain of human knowing. In fact, a point particle, rather than a finite size parental structure, are now declared to represent physical reality and some other things. In characterizing the present situation, it can be noticed that the physical theory is usually dominated by the use of point particle abstractions, yet no physicists truly believe in the reality of point particles. It's merely used as work hypothesis. In virtue, it's mostly of the preventing a too vivid imagination from going wild and making structural assumptions about finite particle structure, like I understand. I mean, if you spend all your life doing this without getting nowhere, so that's really a tragedy. But unfortunately, yeah. But when I think about the electron, I'm thinking about it's kind of must be from sort of the beginning. So let's say the geneticist says it probably has all that universe, and after let there be light, there must be the electron. So there has to be something which is simple, which is kind of strange. But then I would like to invite you to explore the simplicity and to the complex structure, see what it is. Let's say, go back to God. Dirac said that if there is God, he's a great mathematician. And another one, Einstein said, sun is the Lord. Euclid said that laws of nature are but mathematical source of God. There's something with God. And there's one more. He said, physics is simple but subtle. And the question is how the simplicity and subtlety will be combined to get something really describe the thing. First, let's start with, say, if you get the simplest structure you can get is a point. Probably nothing more simple than this. So you move the point, you can get a line. And you move a line, you can get a surface. And moving the surface, you get a cube or any other three-dimensional objects. So this is one way of sort of complexing the point. And let's continue with this one. So it can also extend, we can also get a curved line from a point. And this one you can continue with another one, which will be a circle. By moving the circle one way or another, so you can get a sphere, that's by spinning. But if you do one more, so if you translate it, you get a cylinder, or you get a torus. So these are the probably the most common objects or geometrical objects we have seen. And then the question is there anything we can call the subtle? The thing I can see is here you get the Euclidean geometry and with Pythagoras theorem. But this one, it comes something special, that's pi. Because you have circumference of the sphere is 2 pi r. And these things are also associated with that. But then, if we come back to here and ask another question, what happens if this guy is not lucky? He goes one turn without going to the starting point. So then what you get is something, it has 2 turns. So if you start somewhere like here, it goes around once, well, but without enjoying the end, because it's unlucky, then you have to have a second chance in order to get to the point. So you get 2 times something. And this one, let's see what's special with this one. Yeah, I call this one Huygens helix, because it goes like, if you start, it is not, first of all, it's not a 2-dimensional object, because if it is 2-dimensional, then they go back by 2 pi. You have to lift the 3rd dimension in order not to meet your starting point.